In this example, we have a task which might look familiar to you if you've gone through the first week's material, because we have calculated those sums before. The difference is that last week we have used loops to do it because we didn't know yet how to operate on vectors. However, this week we can do those calculations much smarter with fewer lines of code. So let's try how it works. The first one is the simple case where we have just sum of numbers from 1 to 20. We already know that there is a function in Matlab called sum, and that it operates on arrays. And vectors are the simple case because if we have a vector, whether row or column, once we apply sum on it, we get a sum of elements which are in that vector, which means that we can simply create a vector of numbers from 1 to 20, because these are the ones which are being added here, and then apply sum on it. Creating numbers from 1 to 20 is straightforward. 1 to 20 with the colon operator, which means by default step 1, and apply sum on it, and that's it. There is no more magic to this first example. Let's have a look at second one. There we also had just plain sum, but now the numbers were starting at 15 and ending at 4005, and they have step 10 in between. So that means that, again, I start at 15 with step 10 to my ending number and make sum on top of it. And it's ready. Next one. Now we have some multiplications in here, but we also remember that there is always a relation within those pairs. So the left-hand side number is always less, it's smaller by 2 than the right-hand side. So what we can do is create two separate vectors, or we create one and then have the results, or achieve the result by modifying that first one. So let's actually do both. I will call them point C vector 1. I need numbers from 2 up to 98. And then I could create separately the second vector, which has things from 4 up to 100. And then I would have my final calculation as, I'll call it C1, as my first vector multiplied with the second one, and this stuff would be summed. Sorry. Now, is it ready like this? Not yet. And why? Because CV1 and CV2 are both row vectors, so multiplication like this wouldn't work. This is, remember, the algebraic way, but we don't want to do algebraic multiplication. We want to only multiply pairwise first element of our first vector with first element of second vector, second element of first vector, second element of second vector, and so on. This is the so-called element-wise operation, or element by element. So that means that I have to add a dot in here. So now it will really do what I'm asking it. And this will work only if CV1 and CV2 have the same length. Oh yes, one thing I forgot in here, that actually these values were supposed to have step 2, because we take 2, 4, 6 and so on, and the same case here. So this is one way to do it, but what I could have done is actually use only vector CV1 in my calculation, but like this, that I multiply vector CV1 element-wise with that very vector increased by 2. Now in here, I don't need, here Matlab will understand that it's a scalar that I'm adding to a vector, which means it will add this scalar to every single element in my vector. So which means that all the values in here will now be bigger by 2. So it will start at 4, have step 2 until 98. And then this is not finished yet. We would need to add the sum as well once again. So C1 and C2 actually do have the same results. Let's run this section. And you can see that's the case. Okay, point D. This was the one with powers, so we always have an integer raised to power bigger by 1 than that integer. And that goes up to 10 in the base. So again, we can, it's much smarter to do it using just one vector, which then is modified. So the base vector is just number from 1 to 10. These are the base of our exponentials. And then the result of the sum will be our dv vector raised to a power where each of those is increased by 1. So it will be dv plus 1. So once again, this dv plus 1 will create a new vector which has now values from 2 to 11. And these are exactly the respective exponentials that we have. And the power has to be done element-wise because it's the first element of dv raised to power of first element of dv plus 1, and so on. Alright, and the last case was with the fractions. So once again, I will just define one vector which follows what is in the numerator, and then define denominator respective to that. So I'll call my base vector first EV, and we know that it is changing from 1 to 30 with step 1. Now my E calculation will be, we already know we need a sum, and now those individual fractions. So each fraction is done like this, that it has the base vector, and then it's divided element-wise with sum of that vector and that vector increased by 1. I could have written 2 times EV plus 1. It's the same in here. So we run, and all the numbers come. Oh yes, now I realize in point D I forgot to apply the sum. So we only did the creating of the respective exponentials, but have not summed them yet. All of them were supposed to be summed. Okay, so now the task is complete. Yes, we have some values for all.